Oh, thanks, Tom. Yep, and thanks everybody for coming this morning. So we're shifting topic off of Emiquon here just a little bit and talking about some Asian carp. We're going to be highlighting the early life history of Asian carp, and despite the abundance of research and monitoring that's been undertaken for Asian carp throughout the upper Mississippi River Basin, this is still a life history stage of this fish that's not maybe as well as understood as it should be, given the amount of research that's going on. So hopefully the talk today can to shed a little more light on that by using a multi-collaborative approach. There's many people that contributed to this. Again, we're working across agencies and bringing in a lot of partners here to paint this bigger picture. So they're listed on the screen here, and just like to recognize them at this point. First, I'm just going to start by giving a little spatial context of where we're going to be operating in the upper Mississippi River. I'm going to start then breaking it down by each agency's contribution to this project, and then at the end, kind of showing how we can put all those pieces from those agencies together to paint a bigger picture and make some inferences about what that means. To orient you, we're going to be operating today and talking today about the upper Mississippi River, and specifically upstream of Lock and Dam 19. So if you see my cursor, here's Lock and Dam 19. It's right here at the corner of the intersection of Iowa, Missouri, and Illinois. This has a maximum hydraulic head of 38 feet from pool 19 above to pool 20 below. And that's significant because the only way that fish can get through, they can't get here through this dam, but they can come through. The only way through is through this 1,200-foot lock chamber over here on the Iowa side. So this has restricted native fish passage, and there's been concerns over that over the years, but it's also restricted access to this upper river and slowed the establishment of Asian carp as well. If we look at this and zoom in on this area, here's pool 20 below, there's Lock and Dam 19. We have evidence that this has slowed their expansion just by sheer numbers of Asian carp and size in the system. So below we see high densities of Asian carp below this dam, and they tend to be smaller. Silver carp average about maybe 7 pounds. Bighead carp, when they are present, maybe 12 to 13 pounds. And as you get above the dam, densities are a lot lower. They're a lot more difficult to capture. You might get silver carp average weight somewhere closer to 18 pounds, so over double what you might see below. And so despite because of these low numbers upstream, that reproduction up there has been pretty limited, and there was a few incidences recorded in 2000, 2009, 2010. This is mainly due to some haphazard sampling that was going on up there, some incidental captures. The first systematic effort to look for this early life stages was in 2013. USGS did some egg trawls up there, and they did detect a small number of individual eggs and yolk sac larvae from what they believe was below the mouth of the Rock River there in pool 16. So we have a little bit of evidence here and there that there maybe is some reproduction going on, but nothing at a very large scale. That is until 2016. 2016, we had some students that were going down to seeing some fish for the aquarium there at the field station. And they pulled the seine through one of the creeks, and they started picking up some Asian carp, some young of your Asian carp. They went back and got a trawl, actually dragged a trawl through this small stream, and they ended up collecting in that one day around over 9,200 silver carp just from this little isolated pool right here in this small stream. And here's Lock and Dam 19. Here's the location of that stream. So this was alarming, right? The first time that we've really seen any reproduction up there at this scale. And so it mobilized a multi-agency effort to look for more of these young of year. And so from that effort, we found young of year going all the way up into pool 18 that year, and then down at all these locations at various sizes. Towards the end of the season, we were seeing some individuals as large as 238 millimeters up there. So growing quite a bit larger than we would see them over here in the Grange reach, where you might see them reach 80 to 100 millimeters that first year. So this kind of mobilized a larger effort to, even though it's unfortunate that we were seeing these this large reproductive event, it did provide us the opportunity to try to learn more about what was responsible for this, and put it in more of a spatial context as well. By doing that, we're using several pieces, several agencies and several pieces of the puzzle to put together a bigger picture. And I'll just present a few of those pieces here, and then how they all fit together here towards the end of the talk. Up in this region between Lock and Dam 19 and the next pinch point dams, Lock and Dams 15 and 14, we call this our intensive management zone. And we have contract harvest going on here, and where we actually hire contracted fishermen to go and remove fish. Often they're more difficult to find in this area. They're larger. We use telemetry to help guide our efforts. But from these fish we removed, we were able to get things like gonad weight. We're able to get structures for vital rates, estimations, et cetera. So to kind of contribute towards the early life history story, we were able to remove gonads and do some histological studies, indicating that in this reach that Asian carp in here are batch synchronous spawners. And so that's, they can group synchronous batch spawners where they can put out multiple clutches per year. One individual fish has that potential when conditions are right. And we're also able to record the presence of spawning scars. And if you can see down here, this red patch, this is a fresh patch from a female who has recently spawned. The males have a serrated pec spine that they'll rub against the underside of the female when she's in estrus as they initiate their spawning ritual. We can also use telemetry to help get at what might be happening and where these fish might be going or spawning. We have a very extensive network of receivers. Everything you see here in green and yellow are stationary receivers, so that if a fish passes above or below a dam, or goes up some of these tributaries like the Iowa, the Cedar, the Skunk, they'll be able to be detected by these receivers if they have a tag. And in 2016, we're able to see at least four movements of fish and several fish fairly synchronous up some of these tributaries in the upper Miss. And in addition, we saw individual fish, and some individual fish making up to 3 or 4 individual runs themselves too. And then we're able to, through that telemetry, record things like flow, water temperature, et cetera, that might be responsible for those fish moving up. We suspect a lot of them making these movements to potentially spawn up there. Another piece of this puzzle, as we collect some of these young of year fish, this is work by Jesse Williams, that we're able to take the otoliths. If you can see on this slide, this is a otolith from a young of year Asian carp. It's an ear bone. It's very small, and you can section these or polish these down to reveal these rings. And a young of year fish will put down daily growth rings so that we can count these and back calculate a hatch date for this individual. Okay, so we can get hatch date for these individuals. And then from the other otoliths, we can use the elemental composition of the water compared to the elemental composition of the bony structure to determine where this young fish lived its early life, or where its nursery or spawning habitat was. So we go towards the core right when it was forming, when the fish was being born, and looking at the strontium calcium, barium calcium ratios, and the stable oxygen isotope, we can then determine some tributaries have a unique signature, and if it's held early on in the otolith of that fish, we can attribute that fish being spawned or spending its early life in that tributary. We also have light trapping going on. We had somewhere around 640 light traps set in 2016, all the way from pool 17 at the top, up to Muscatine, Iowa, down to the bottom of pool 19 to Keokuk, Iowa. These yellow dots just show all the sampling locations for 2016, focusing on backwater and slackwater type areas to set these traps. And during this time, I think it was captured around 1,700 Asian carp during 2016. And then we're able to back calculate the hatch date from those. We could actually remove otoliths from these larval fish, which, if you thought the last slide was tiny, last otolith on the slide was tiny, these are extraordinarily tiny. But we're able to get counts around average about 10 days for most of the fish caught in the light traps. So then back calculating those then to get a hatch date for those light trap captured fish. Another piece of the puzzle is that at Iowa State, they are doing egg trawls above and below and inside the major tributaries in this area. So here's Lock and Dam 19 down here. There's the Skunk River coming into pool 19, the Iowa and the Cedar River coming off here, coming into pool 18, right below Lock and Dam 18. And then the Wapsipinicon coming into pool 14, the Rock River coming into pool 16. So we have egg trawl data from them as well. Okay, I'm going to now start trying to put these pieces together and walk you through, how some of these things line up during this year and what we can learn by putting some of these pieces together. This is going to be kind of busy, so kind of bear with me here. I'm going to try to walk through it step by step. This black line that we see here, this is the Skunk River hydrograph. And these axes are going to remain the same. This is time in 2016, and this is river stage on the y-axis. So every peak or inflection you see here is basically an increase or in magnitude of discharge in that particular stream or tributary. And so these are typically produced by heavy rainfall events. Like you get these heavy rainfall events, you get these flash flooding events that really swell these streams and increase the river stage rapidly. If we add the red is the Iowa River. Remember, the black's the Skunk River coming into pool 19, the red is the Iowa River coming into pool 18. And again, these peaks are large increases in the volume of water within these small tributaries. So in discharge in those tributaries. Now I'm going to start plotting some of the points from some of the observations from the larger group and how they fit into this. These triangles are spawning runs, and most of these are represented by several fish, all moving together at once. They're all following a similar cue. Blue, if you look up here, blue is bighead carp, and then the purple, kind of pinkish purple, is silver carp. And this is for fish that are on the Skunk River. All right, Skunk River movements first. They're the solid ones. So here we see bighead carp and kind of lining up with some of these peaks here on the skunk. If we add in Iowa River movements, this is bighead carp Iowa River movements here. They're the ones that are kind of shaded with the outline. And the silver carp movements on the Iowa River, right? So we're getting fish moving up the skunk and Iowa here, skunk and Iowa here, mainly moving up the Iowa here, Iowa here. And then adding in these two, these are actually individuals that moved up the Cedar River, which is connects to the Iowa River before it empties into pool 18. So these are kind of, and they're connected, and it's natural what we'd see a logical, or those two moving together. So. Okay, so those are all telemetry movements for the fish. So again, we don't know they're spawning at this point, but we know that they're going up there for a reason, and they're making these multiple trips up these tributaries. This green dot is the presence of one bighead carp and one silver carp egg that was taken from the Skunk River from Iowa State. And this is one silver carp egg that was collected from the Iowa River. So all their egg trawls throughout that season, they were able to capture one individual, probably attributed to this cluster of movement here, and then one individual up here that's not yet assigned. These little boxes down here are the spawning patches. These are areas or times when we observe spawning patches. These are predominantly observed from places like New Boston Bay from Pool 18, Cleveland, and Big Timber backwaters from Pool 17. So again, these spawning scars just following these movements, just following the pickup of these eggs here. And this is silver carp spawning scars, lining up here, an additional one over here on the presence of those fresh spawning scars that we see, indicating that that fish has spawned recently. Now, if we start adding into some of the hatch dates from the microstructure, right, we were able to calculate hatch dates from those young of year. We're starting to really start to flesh out this picture a little more, right? So every diamond that we see here is a particular cohort or hatch date that's been, that the fish, indicating a spawning event for those fish. So as you can see, we have quite a few, 10 unique hatch dates in this section of river. And a lot of these are lining up really closely with these big aggregations here, and then these on these large peaks right here on the Skunk in Iowa. Now, if you remember, I also mentioned that we are adding in microchemistry to those as well. And so these have, and from those microchemistry signatures, we're able to determine that 8 of those 10 cohorts, at least one individual had a tributary signature from those.
About a minute.
Okay. So this indicated that we had at least potentially 11 unique spawning events by putting all these pieces of the puzzle together. If we look at this, was the main stem was below flood stage pretty much this whole time, and you know, and most of the time, large increases in discharge in the main stem are associated with Asian carp reproduction in some other areas. However, this time I think we're seeing most reproduction being attributed to those tributaries.